Given the polynomial 2x squared times the quantity of x plus 2 times the quantity of x minus 3, complete the following. Well, even before we get there, I think what I want to do is I want to start by graphing. So I'm going to grab my calculator. I'm going to go to y equals. And it might be nice if you could see it here, but if we type this in, it's 2x squared times x plus 2 times x minus 3. And notice down here that we do have a window. So I'm going to come over here to the window, and nothing for the x's changes, but for the y min it's going to be negative 40, and the y max is going to be positive 40, and we're going to go for a scale of 10. So we've got it typed in. This gives us a little bit of a picture, and I'm just going to do a real rough sketch over here, and I do that just to kind of give me an idea of what I'm working with. So something like this. So there's our picture. And did I really need that to deal with the degree? No. Just a reminder that the exponent on this is a 2, the exponent here is a 1, the exponent here is also a 1, so 2 plus 1 is 4, which means that this particular polynomial is a quartic. The number of roots, since our degree is 4, we'll have 4 roots. The leading coefficient, well, 2x squared is positive. The maximum number of turning points is 3, 1 less than the degree. And if we look down below at our picture, what we see is that as x goes to negative infinity, our graph is going up to positive infinity. As x goes to positive infinity, y also goes to positive infinity. Both of our ends are going upward. In terms of roots here, we can take 2x squared and equal 0. But by the way, the squared is the multiplicity. So if you have to do the work, you can divide both sides by 2. You get x squared equals 0, but when we take the square root, we still end up with 0. So one of our roots is 0. In fact, that makes sense when we look at the picture here. Right there, 0, 0. And what we see is that it touches the x-axis, and it is a U-shaped curve, which means it's a quadratic. Our next root is coming from the next parentheses, or the first parentheses, rather. If we subtract 2 from both sides, we get x equals negative 2. The multiplicity is coming from the exponent. We wrote the exponent of a 1. So our multiplicity is 1. So we're going to cross, and our behavior is linear. Our root there, negative 2, is here. I don't want to put it in because we're going to look at increasing and decreasing in a minute. I don't want to confuse. But one more root coming from our second parentheses, the x minus 3, equals 0, and we can add 3 to both sides, and we get x equals 3. The multiplicity is coming from the exponent on our parentheses, which is 1, and it also crosses, and it also is linear. Here is where 3 is. You can see the slice right through. The y-intercept, it says determine algebraically, but if we look down the picture, we see that it's 0, 0. If you need to determine it algebraically for some reason, let x equal 0. Put 0 back in for this. Oh, you got to be able to see it. Put 0 back in for this x, put 0 back in for this x, and 0 back in here for this x, and calculate it out with your calculator, and you'll still get 0 for your y value. We used our graphing calculator, we sketched it to the right, But now we need a little bit more information. We need to know what this point is right here, and we need to know what that point is right there as well. So if we grab our calculator again, we're going to go second and trace, and these are minimums. These are low points in the graph. So I'm going to go to 3, and I'm going to go a little bit to the left, enter, a little bit to the right, enter, and then enter. And what we get is we get negative 1.4, negative 10.3. So that's that point. Then over here we're going to do the same thing. So second, trace, minimum. It's another relative minimum. We're going to go a little bit to the left, enter, a little bit to the right, enter, and this point is 2.1 and negative 32.6. And now we have what we need to figure out where we're increasing and where we're decreasing. When we start coming from the left, we go down, 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 down. So we're going to be decreasing here from negative infinity to the x value of this point, which is negative 1.4. Once we get to this low point here, we start going up, 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 up. So this is going to be negative 1.4 to 0. But then we start going down, 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 down. So I'm going to use U. If you don't like U for joined with, then use and. We're going from the x value of this point, which is 0, to the x value of this point, which is 2.1. And then we finish by going up, 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 up. So again, I'm going to use a U. If you don't like U, put and. And then we're going to be 2.1 to positive infinity. And it's positive infinity because we're looking at the x values, not because the graph is going up to positive infinity. Lastly, the domain of this function is all real numbers. But the range is not all real numbers. We're looking at whether we have a high point or a low point, and we have a low point. The lowest y value on this graph is negative 32.6, and we keep going upward on the graph to infinity.